you. It's nice to meet you. Hi, everybody. We're here to help Miss Mute pick a mate. She wants to have a child with one of these fine studs here, and she wants to know what the probability will be of getting a mute child with one of them. We've got Jean here, and we've got Finny here. Let's figure out how we do it. Is that right? Okay. So, it's true, Miss Mute, that mutism is a recessive allele, right? Well, that's a great question. A recessive allele is a version of a gene that has its expression hidden by a more dominant version of that same gene. Yeah, so on a chromosome, which is a big piece of your DNA, you have genes, which is a segment or a sequence of that DNA, and which is called a locus. And at each locus, you can have versions of the same gene. Does that make sense? One that's for mutism and one that's not. And since we know that you're mute and that mutism is recessive, you have two little m's at that allele. That's right, your genotype is MM. Your phenotype, which is how your genes are expressed, would be mute. That makes you a homozygous recessive for mutism. So, let's get started. For Jean here, this wonderful little stud, we know that he has one mute parent, and his other parent has no history of being mute. Which means that because he's not mute, he's got to have a big mute, a big M, and we also know that because one of his parents is mute, like you, he's got to have a little m. And his phenotype is non-mute. He's non-mute because his big M hides the effects of the little m. Okay, great. Let's move on. Let's do Finny real quick. Finny is non-mute. That's his phenotype. We know that he has no history of mutism on either side of his family. And that implies to me that he doesn't have any little m's at all. So his genotype would be big M, big M. Make sense? Doing good so far? Great. So let's do the probabilities. Let's start with you and Jean. So I'm going to have you draw a Punnett square. So, Miss Mute, you're going to put one allele over each column. And we know that you're little m, little m. The probability of you throwing a little m is 0.5 for each. We know that Jean is a big M, little m. And for him, the probability of throwing a big M is 0.5. And the probability of throwing a little M is 0.5. So we know that your offspring is going to get one allele from you and one allele from gene. Perfect. And we can figure out what the probability of getting each of these genotypic combinations will be. It's 0.5 from the little m for you times 0.5 for the big M from gene, which would equal 0.25. And that's the same for all. Perfect. So we know that the phenotype for mutism is little m, little m. And in this Punnett square, we have two little m offspring possible. So what that means is to find the probability of getting those, we times 0.25, we add 0.25 plus 0.25, and that'll be your probability of having a mute child. So you have a 50% chance of having a mute child with gene. I know, that's a really bad probability. Okay, let's go on and do Finney and see what we can get with him. Let's do another Punnett square. And again, we know that you mismute. Are little m, little m. With a possibility of passing on one of those alleles, 0.5 for each. We know that Finney is big M, big M. He's homozygous dominant for mutism. And the possibility of him throwing a big allele is 0.5 for each. Great. So, one allele from you and one allele from him, and we get the genotypes of well, my, all of those are the same genotypes. And we know from gene that with a big M, little m genotype, he was a non-mute phenotype. So, we have all four possibilities being non-mute. That means there's 0% chance of having a mute child if you were to mate with Finney.